Alright, so I have a video here on the molarity practice so that you guys can get ready for your test. And we're going to look at number 1. So number 1 is giving you 6.73 grams of sodium carbonate. And it's telling you it's being dissolved in 250 milliliters of water. So then it's asking you for the molarity, which is pretty much the concentration. Okay, so we know that the formula as listed above is molarity is equal to moles divided by liters. Our givens are going to be obviously our grams and then our 250 milliliters. Okay, a couple of things to keep in mind. First of all, they're not giving us moles, they're giving us grams. Second, they're not giving us liters, they're giving us milliliters. So easy fix. Okay, so we start by converting 6.73 grams to moles. So first we're going to need to find the molar mass of sodium carbonate first. Okay, so just by looking at the formula, we know that it's 2 sodiums. There's not a number here, but it's understood as 1, and that's carbon, and then there's 3 oxygens. So then we're going to multiply by the mass on the periodic table. So looking at sodium, it's 22.99. There it is, which is where I got this information. Okay, carbon, same thing. On the periodic table, it's 12. And then oxygen on the periodic table, it's 16. It's 15.999, just rounded to 16. So once you multiply the 2 by the 22.99, gives you 45.98. 1 times 12, 12. 3 times 16, 48. You take all 3 numbers, you add them, and there you go. That's a molar mass. Okay, now that you have that information, we go on to the following. So now it's about changing those grams to moles. So using that molar mass, we know that there's 105.80 grams in 1 mole. Okay, we want to make sure that the units are diagonally matching each other, and that when they cancel, we're left with whatever it is that we need to find, which is moles. So in this case, we're going to take the 6.73, multiply by 1, and then divide by 105.98. That gives us 0.0635 moles, which I chose to round it to 0.06 moles. Okay, from that point on, now we have the moles. Remember that, as I said before, you need moles per liter. So we've got the moles that we need here. Now we need the liters. They give us milliliters, so we need to convert it to liters. And we know that 1 liter is equal to 1,000 milliliters. So what we do is we take the 250 that was given to us, we divide by 1,000, and that gives us a 0.25 liters. Okay, at this point, we're ready to go. So we've got our moles, there it is, and we've got our liters. There they are. You plug them into the formula. So you put 0.06 moles divided by 0.25 liters. You divide the top by the bottom, and you get 0.24. And this is concentration, molarity, but you can also put 0.24 moles per liter, because technically this is the same as this. It's just however you choose to express it. And that would be the answer for number 1. Okay, for number 2, it's asking how many moles of solute are in 250 milliliters of a 0.02.0125 molar solution of potassium permanganate. Okay, first of all, no G's, no grams mentioned. That means we don't have to find molar mass, which makes it a lot easier for us. Okay, so same formula, but you're going to manipulate it. So manipulate it means rearranging to where whatever you want to solve is by itself. So we want to solve for moles, and to solve for that, we're going to multiply molarity, which is concentration, times liters. Okay, so they give us molarity. It's right there. They don't give us liters, they give us milliliters. And like we did in the last question, all you have to do is you either divide the 250 by 1,000 or simply shift the decimal 3 times. So 1, 2, 3 times to the left lands on in front of the 2, so it will be 0.25 liters. Okay, so the rest is pretty much simple. You plug it in, so our molarity, 0.125 molar, and again that's from what was given to us. And then our liters, or our volume, which is 0.25, we multiply, and our answer is 0.03 moles. Something I want to remind you is that I know there's an M, so you might be wondering about the units, or either that or you just don't care. But in any case, molarity is moles per liter. So when these liters cancel, you're essentially left with moles, and that's why it's moles as in your answer as your units. Okay, so now we're in question 3. Question 3, it's asking what volume. So still using the same formula, we're going to manipulate it. So we're going to find the liters, and it would be the moles divided by the molarity. Okay, so these are the things we're given. We know we're given the concentration, which is right there, and we're given this mass. But we don't want to have it in grams. We want to make sure that it's in moles. So just like we did before, like in number 1, we're going to need to convert those moles by using the molar mass. Okay, so calculating the molar mass. We have 1 sodium, 1 oxygen, and 1 hydrogen. We multiply by the mass on the periodic table, which is the same. You add them all together, and then it comes down to 40 grams per mole. Okay, so now you're going to convert those 25 grams that you have into moles. And just like we did before, again, it's 40 grams per 1 mole. It's going to be 25 times 1, which is the same, divided by 40. And that's going to give you 0.625 moles. So yay, now we have the moles that we need in our formula that we need to use, which is moles divided by molarity. Okay, so there's our 0.625 moles. And then, of course, our molarity was given to us, 0.123. And you divide the top by the bottom, and you get 5.08 liters. So that's what the volume is in liters. Although in the question it says what volume in milliliters. So if we want to find what this is in milliliters, it's really, really simple. All you have to do is take this number and you go ahead and you multiply it by 1,000. So in this case, instead of shifting the decimal like we did to your left, you're shifting it to your right 3 times. Okay, it's kind of hard to write, but there it is. So it's 5,080 milliliters, which is the same as 5.08 liters, but because the question is asking you milliliters, then that's how you would express it. Okay, so you're finding out that you're a rock star on molarity. And so we're going to go into dilution problems. And this is when you make something concentrated into something diluted and you can find it all mathematically. All right, for the first one, it's giving you the information that 4 milliliters, you have 4 milliliters of a 0.025 molar concentrated copper sulfate solution, and then it's diluted to 10 milliliters with pure water. So now it's asking you what is the concentration after diluting it. Okay, we're using this formula, which I think is a lot easier. So it's the first molarity times the first volume is equal to the second molarity times the second volume. Okay, So those are all our givens based on the question that we have above. And all we have to do is plug it in. Okay, so there's a plug-in process. There's our givens. And we're trying to solve for the second molarity. Okay, so we have 0.0250 times 4. And in order to isolate, which means leave it by itself, we're going to bring that 10 milliliters over and under by going ahead and cancel it by dividing by itself. So 10 divided by 10 would be the same thing. What you do to one side, you do to the other. So it's going to be 0.0250 times 4 divided by 10. It leaves a molarity, or the second molarity by itself. You just do the math. Multiply the 2, divide by 10. And you're left with a molarity of 0.01 molar concentration. Again, or if you want to put moles per liter. Either way, same thing.